Today's lesson is on acid naming. So acids have their own naming system because they're not quite ionic compounds, but they're not quite covalent compounds either. An acid is a hydrogen atom attached to an anion. And so but they're covalently attached. So when an acid is put into water, a hydrogen ion and an anion are formed despite being covalently bonded. So because of this unique situation, the anions are actually what determine the name of the acid, and like I said, they have their own naming system. So the first type of anion that we could have is a monoatomic anion, which is an anion made of just one element. So the way that a monoatomic anion forms an acid with the naming system, the basic pattern is hydroblankic acid, where this blank here is the root of the element name for the anion. So for example, HCl is hydrochloric acid. And if we were to have H2S, that would be, because this is a monoatomic anion, it's only one element, then we use hydro. And then sulfur is our anion, but because we change the ending to ic and add acid, so it's hydrosulfic acid. Okay, the next type of ion that we could have is our polyatomic ions. And polyatomic ions are slightly different. The first type of polyatomic ion that we could have is an ion that ends in 8. So when you have an ion that ends in 8, you're going to change the 8 to ic and add the word acid. So here in H2SO4, the SO4 is our anion, and the name of that is sulfate. So in order to find the name of it, you're going to cross out the 8, turn it into ic, and add acid. Now sulfuric acid sounds kind of funny, so it is actually sulfuric acid. But if you were to put sulfuric acid on a test, I would still give you credit for that, full credit for that. Another one is HNO3. The anion for HNO3 is nitrate. So we're going to cross out the 8 and turn it into ic and add the word acid. So without the work, that is nitric acid. The next type of anion is one that ends in ite. And so when you have an anion that ends in ite, you change the ITE to OUS, and again we add the word acid. So if I have, it should be HNO2. That should be a 2. If I have HNO2, the anion there is nitrite. So then we take the ite, change it to OUS, and add the word acid. So it's nitrous acid. Another one is H3PO3. And the anion on that is phosphite. So again, we change the ite to OUS, so it becomes phos. And again, phosphorus sounds a little funny, so it's actually phosphorus acid. Okay, now going from name to formula. Again, we have to identify we work with the anion. So we use the name to identify what the anion is. And once you've identified the anion, so hydro is a monoatomic, again, still a monoatomic anion. If it has hydro in it, then it was a monoatomic anion. If it ends in ic acid without hydro, then the anion ended in ate. And if it ends in OUS acid, then the anion ended in ite. So once you identify the anion, then the charge of the anion will tell you the amount of hydrogens to put in the front of the anion. So if we look at hydroiodic acid, because we have hydro here, then we know that it was a monoatomic anion. So the anion, it comes from iodine. And iodine, if we look at it on our periodic table, the charge of it is I-1, which means that we need, since the charge is a -1, we only need one hydrogen. So the formula is then HI. Another example is sulfurous acid. Because it ends in OUS, then that means the anion is sulfite. And sulfite's formula is SO3 minus 2. Because it has a -2 charge here, then that means we're going to have two hydrogens. So H2SO3. And you just get rid of the charge on it. Okay. Another example, if you have sulfuric acid, and in this case it ends in ic, and there is not a hydro there. That means that that the anion ends in ate, so the anion was sulfate, and sulfate has an SO4 minus 2 charge. So that would give us two hydrogens. So it's H2SO4 is our formula. So that's how you name acids and write formulas for acids. Make sure that if you have any questions to let me know, or if any questions come up on the homework, send me an email. Thanks.